Greetings and good evening towards my supervisor, Ms. Mogeret, my examiner, Dr. Effendi, all the lecturer, and my classmate. Hi, my name is Isaiah John, matrix number 66175. So today, I would like to present my final year project proposal, which is the occurrence different type species of bagworm in all palm plantation in Samarahan area. Oil palm industry is one of the largest contributor to the economy of Malaysia, as it is one of the important commodity crop. There is a major concern about the occurrence of the pest with the rise in hectares of the oil palm planted area, which has often resulted in significant loss of yield. This may eventually cause problems, as the pest will continue to damage the oil palm and affect the oil palm production yield. The most common pests in the oil palm plantation are bagworm. Bagworm are the leaf-eating caterpillars that are characterized by its possession of bag, which they build out of tuck silk. While in Sarawak, particularly in Samarahan, the study of bagworm occurrence in the oil palm plantation is still lacking. Even some plantations have been experienced bagworm infestation. The objective of this study is to investigate the occurrence different species of bagworm in the oil palm plantation in Samarahan area. Moving on to the literature review, pests in oil palm. According to the study done by Norman et al. In 2019, the oil palm remains vulnerable to threats by a variety of pests such as insect, vertebrates, and disease. The major pests for the oil palm are the rhinoceros beetle, bagworm, nettle caterpillar, termites, bunch moth, and rats. Bagworm species in the oil palm. There are 7 species of bagworm that are found on oil palm, which are the Metissaplana, Petroma pendula, Mahasena corbeti, Brachytyrus gyresius, Manata albibes, Amitasa species, and Cryptoptelia cardiophaga, as stated by Norman et al. In 1984 and Sakharan in 1970. However, Metissaplana, Petroma pendula, and Mahasena corbeti are the common species of bagworm found in Malaysia and capable of causing outbreak in the oil palm plantation. In Peninsular Malaysia, Metissaplana was the most widely distributed bagworm species, followed by Petroma pendula, while Mahasena corbeti was widely distributed in eastern Sabah, as stated by Norman and Basri in 2007. These are the life cycle of the Metissaplana, Petroma pendula, and Mahasena corbeti, according to Cheong and Tay in 2012. There are 2 factors influencing the infestation of bagworm, which are the biotic and abiotic factor. For the biotic factors, the first one is the application of pesticide. According to Prince in 1987, one of the widely recognized consequences of the application of pests is the natural enemies suffer greater impact than the pest species. Indiscriminate spraying for the bagworm control are more likely to kill the natural enemies more extensively than the targeted pests, as stated by Wood in 1971 and 2002. Next is the alternate host plan. When the oil palm are treated with insecticide, Cheong and Tay in 2003 mentioned that bagworm will migrate and survive on the alternate host plant, which are shades tree and agriculture crops such as coffee liberica, Cocos nucifera, and Theobroma cacao. For the abiotic factors, the first one is the temperature. Both the Metissaplana and Petroma pendula has the capacity of increasing its population at 30 degrees Celsius to 35 degrees Celsius, which indicate that the optimum performance of these two bagworm species as stated by Ho in 2002 and Ibrahim et al. In 2013. Next is the rainfall. According to the study done by Shade and Shah in 1977, rain can affect the bagworm population by promoting the entomopathogen activity to occur. Moving on to materials and method. For this study site, the research will be conducted at Sungai Su in Kota Samarahan. For the setting of plots, 4 blocks planted with 7 years old of oil palm were chosen. Size of each plot of experiment was 30 meter in length and 100 meter in width. For the bagworm collection, it will be done every 2 weeks. Selection of oil palm tree. Sampling will be performed on 2 randomly identified oil palm trees from each block where it will be marked with safety barricade tape. Labeling. The safety barricade tape used will be labeled with the date of sampling, plot, and oil palm tree number. Observation and cutting. The freshly damaged frond are being observed before cutting it using a frond cutter. Collect this sample. The leaflet will be collected together with the bagworm larvae and pupae before placing it inside the plastic aquarium tank and bring it back to the laboratory. Record the data. Time of sampling, data of temperature, rainfall, and pesticide application will be recorded every time the sampling being done. For the sorting and identification, the live and dead bagworm will be separated. The live bagworm will be sorted into different groups according to their species and being sorted out into the different stages of instar by observing the length of bag. The alive bagworm larvae are being nurtured from metamorphosis stage to adult stages or until death. While for the dead bagworm, they will be sorted into different groups according to their species also, and will be sorted out into which are with or without bags, small or big hole, or infected with fungus. The dead bagworm are being looked into about how it died or what causes it to die. The dead bagworm larvae will be kept to observe if there are any presence of the emergence of their parasitoids. For the data analysis, all data will be analyzed by using a one-way ANOVA and further run on a computer software SAS version 9.4 statistical software. Significant level in all cases will be set to alpha equals to 0.05. The expected outcome. The expected outcome of this study is the occurrence number of bagworm will be varied as affected by various factors. Work schedule. These are the work schedule for this semester and next semester when it will be done. My references. That's all from me. Thank you.